Hello, and welcome to the Outlier podcast, the podcast for everyone who is interested in building better homes. My name is Anthony, and I am the founder and lead designer of Outlier, and I'm passionate about creating beautiful and high-performing homes. I sit down regularly to chat with industry experts to help educate Australians about the potential of creating healthy, comfortable, and energy-efficient homes. Whether you are looking to build your forever home, renovate your existing house, or simply eager to learn more, tune in every month wherever you get your podcasts. We hope you join us on this journey. I have been very fortunate with the journey of this podcast to chat with many experts and knowledgeable people. As new people come to the podcast every week, we want to take all the highlights and helpful information from previous discussions to provide them to you to assist you with your own high-performance home journey.
All right. Thank you again, Anthony. This is going to be the episode with the two Anthonys, so pardon me if anyone listening is confused. We'll try to make it as easy to understand as possible who we're chatting to, but I'm hoping the majority of the time it'll be Anthony Stagg, who I've just introduced before. Thanks for taking the time today, Anthony.
Pleasure.
Can you just tell our listeners what your background is and how you got started in providing knowledge and kits for blower door tests?
No, not a problem. Not a problem. Where would I start? I would start in the 1990s when I first was employed in the fire industry.
Yeah.
And that was my first introduction to a blower door kit, which looks totally different from the blower door kit that you picked up recently. But the fire industry itself was using blower door technology to visually find leakage points within an enclosure that was protected by a fire suppression system, a gaseous fire suppression system, which was a move away from traditional water-based fire protection systems that we may all traditionally sort of see in buildings like sprinkler systems.
Yeah. And how did you kind of find your way into that specific industry?
Oh, by chance. By chance. So I actually was studying architectural technology when I came out of high school. And so I finished a diploma in architectural technology, or an advanced diploma, and I had good drafting skills. So I applied as a trainee draftee for a fire protection company and started to learn how to design fire systems and draw up the plans for them. And it just evolved from there. From there, I completed a diploma in fire technology and then continued on my journey in the fire protection industry, and then eventually finished some postgraduate studies in fire and risk engineering.
Yeah.
So my career is very fire orientated,
Yeah.
but now I'm also a director of a company called Energy Conservation Technology, which basically takes the blower door and uses it for energy efficiency.
What do blower door tests do? And I mean, I guess they identify air leaks, but why is that important?
Well, if we start with the equipment, there's really no difference between a fire blower door system and an energy blower door system. They do quantify leakage. They use different types of software, but they do quantify leakage. So the blower door system is comprised of a fan, a digital manometer, and we put that fan in a doorway, and basically we are depressurizing and pressurizing the enclosure, and we take measurements with regards to induced pressures and what sort of leakage rate we are having at those varying pressures. And from that, we can actually quantify in a singular point what is the collective leakage of an enclosure. In fire, we use that total leakage area, and we CFD model the impact on the gases, because they have a different density than air, and they behave differently across an opening, with gravity pulling down these agents through these openings. So we can model that. And when it comes to energy efficiency, it's interesting because we model that with regards to energy efficiency. Just how leaky an enclosure is, because it can impact on how much energy you're using with regards to heating and cooling, and your comfort levels, as well as other things like pollutants and so forth. So we don't often visually see much leakage in an enclosure when we walk through, but if you do a blower door test and you quantify that leakage in a single hole, you would be dramatically surprised how big that actual hole is. It would be like leaving a door open potentially, or leaving a window open permanently.
Yeah.
So when we see it in a singular form, we realize that is unacceptable. But when you break that whole single leakage area, into finer leakage points that you can't see visually, we don't notice it. And it can play havoc on our comfort levels and our energy bills.
Yeah, I have to admit that that was probably, it still is the most exciting part, is that initial depressurization of a home and just walking through it and just being astonished by where air is infiltrating and just how much.
The blower door system, to me, it doesn't lie. It actually tells the truth. When you, like you said, when you subject a home to a depressurization or a pressurization and use a handheld smoke puffer on suspect leakage areas, there are so many that you can add up through every aspect or area of your home, whether it's through doors, windows, through power points, through wall cavities that haven't been capped off, you name it, and through fans, exhaust fans. You add all those up, and you're shocked at the total level of leakage area that your home has. And once you explain that to a homeowner and say, look, I'm going to leave your window open permanently throughout the year, they would say, you can't do that. That's unacceptable.
Yeah.
I would be so cold or so hot during the summer, and my energy bills are going to be enormous. But they actually have that. It's just broken up into smaller points in various parts of the house.
Maybe we can chat about your own home, Anthony, and share your thoughts.
Yes, let's embarrassingly talk about my own home. So I bought a home nearly a decade ago. Original house was 1959. And there was an extension for the previous owners to increase the size of the house. But last year I embarked on a renovation. Now, I'm not going to the extent of passive house, but I did subject my house to a blower door test before we started the renovation, and I'm going to complete, post renovation, I'm going to subject the house to a blower door test. My results on the existing house was about 30 air changes per hour at 50 pascals of induced pressure.
Could you give our listeners a little bit of an overview of what is good and what is not so good?
So with the volume of your house, and I'll try and keep the numbers simplistic, let's just say that your house is 500 cubic meters of volume. You've measured up all your area of your house and multiplied that by the height to work out what the volume of the house is. One air change. So if my house was 500 cubic meters of volume, then one air change would be 500 cubic meters per hour. And my house was 30 times that. Now, that's at an elevated pressure at 50 pascals used with the blower door, so the process can be repeated with accuracy. The house is probably naturally not going to be subjected to 50 pascals of induced pressure unless you're in some sort of cyclone conditions. So the house does cycle with regards to external influences that put pressure, negative and positive, on the house, and they could range anywhere between sort of 0 to possibly 5, 6, 7, possibly even 10 pascals. Depending on the conditions. But we test at an elevated to 50 pascals so we can redo with accuracy. So yeah, one air change is one volumetric change of that house per hour, and mine was measuring 30 times that, which is atrocious. So you could imagine when you're trying to heat or cool a home. If it's that leaky and the volume of that home is changing per hour, it would be just, it's like leaving, putting your heating and cooling on and just leaving a door or two open. So my house was 30 air changes per hour. Passive house, if you were certifying your house to passive house, it's 0.6 of an air change. So it's not even one air change.
Yeah.
Because passive house is really quite a strict technique for design, materials, construction techniques to ensure that your house is very energy efficient. You would only go down to a 0.6 or close to 0.6 for passive house if you had some sort of heat recovery system, because you do need some exchange of air, because you have occupants, you have cooking, all these sorts of activities in the house. So you do need to change the volume of the house, but it needs to be controlled. And that's what a heat recovery system does. What is good these days, I've done a couple of blower door systems for some new houses that should be sort of 6-star rated and so forth. And some of them are quite respectable at anywhere between sort of 8 and 10 air changes per hour. So, what is good? I would say today, if you didn't have any thought associated with air infiltration or air leakage, 10's probably a good point.
I think a big question that people would have would be, is a blower door only something if you're considering passive house, which I think you've kind of already answered, that is not. And B, when is the right time to get a blower door test done? Because as I understood it from you talking before, there are several different occasions where you get the blower door test out in your home. Is that right?
Yes. So for anyone that's doing a renovation or a build, or whether it's passive house or not passive house, you would want to subject the house to a blower door system before the plaster goes on.
Yeah.
Because once the plaster goes on, and sometimes you are using the plaster as the air barrier, but then it's probably too late if you do have leakage points behind the plaster. So you don't want to be ripping down your internal skin to try and find these large, potentially large or minor leakage points. So during the construction process, once the trades have gone through, it would be nice to subject the house to a blower door test, because you can quantify it, but not only that, you can use the blower door system to create a positive pressure of about 15 to 20 pascals, walk around the house with either a thermal camera or just a handheld smoke puffer, just to subject some of those suspect leakage points. And if you've got an induced pressure at 15 or 20 pascals, it's going to push that smoke out dramatically. You'll be able to, visually see the smoke being sucked out to outside, because you've got a positive. You're inducing the house to a positive pressure. You're blowing it up like a balloon.
Yeah.
And it's a great way to just walk around and just take note of where all these leakage points are, address those, and then you put your plaster on and subject your home to a final a blower door test. But anyone that it doesn't have to be a renovation too. It could be, you can still organise a blower door test for just a house that wants to, homeowners that just want to improve their level of energy efficiency. So there are some basic things that they can do, whether it's sealing up windows and doors a bit better, or extraction ventilation. You're sealing up the cavities on top of walls if they get into the roof cavity or space. There's certain basic things that can be done just to improve a house that's already been built.
Thank you for listening to the Outlier podcast. You can find helpful links and contact information regarding this episode in our show notes and on our website, outlierstudio.com.au/podcast. If you like our show, please leave a review and make sure you subscribe to never miss a new episode. If you have further questions for us or would want to share some additional feedback, please feel free to DM us on Instagram or Facebook. Until next time on the Outlier podcast.